And I'm standing here for what in nice technical language is called Topic 1. Doesn't tell you much. Topic 1 is sort of the first part of the Sensor report, and our topic is observe changes in their causes. Now, by that we mean not only changes in capitalism itself, but also changes in impacts of
capitalism,
but also what changes led to the
capitalism
that we observed. So the changes in the causes are to be interpreted in very, very broad terms. Let us start with observations of two of the most central capital indicators, the global average surface temperature and the global average sea level change, and shown here as time series over the last 160 years or so. For sea level, we only have data since around 1900. Both are going up. That is by now probably no surprise to anyone in the room here. In case you think your glasses are a little blurry or the screen is, no, it's not. There are several curves shown where we have that because there are several independent reconstructions of the global average surface temperature from the available station data, likewise for the sea level. And the difference between these different curves gives you some idea of the observational uncertainty. And these, of course, are some of the most important indicators, and the assessment in the Census report is this, taken verbatim from Working Group 1. Warming of the capital system is unequivocal, and since the 1950s, many of the observed changes are unprecedented over decades to millennia. The atmosphere and the ocean have warmed, the amounts of snow and ice have diminished, and sea level has risen. This is what the physical parts of the capital system tell you. Now, what we could in the Sensor report, we can tell to some of the, well, you could say the biogeochemical part. The top graph shows you the three most important greenhouse gases: in green, carbon dioxide; in orange, methane; in red, nitrous oxide, and they have all gone up, most markedly since 1950. And in the bottom panel shows you the time series back from 1850 of the carbon dioxide emissions. For reasons that I will come to, this is the most important greenhouse gas. And especially since 1950, the emissions have gone up. You see in gray, it's the emissions from fossil fuel burning and other industrial processes. In ochre, it's the land use part. The land use portion has gone down, but the increase in CO2 emissions from fossil fuels has more than made up for that reduction in CO2 emissions from land use. On the right panel, you see the cumulative emissions of CO2 from 1750 onwards, so a bit further back than the time series shown here. And the left column there till 1970 and the right one till 2011. And what you can see is that the CO2 emissions in the last 40 years are as high as they have been in the 220 years before that. 220 years, one number; 40 years, the other number. So just another measure of how much the CO2 emissions have gone up. And so our assessment was this: anthropogenic greenhouse gas emissions have increased in the pre-industrial area, driven largely by economic and population growth. There are some other things you can imagine, but it is the economic growth and it's the population growth that are the most important drivers, and are now higher than ever. Anthropogenic emissions are higher than ever. Than ever has been questioned by some governments. Well, how can you say forever? How can you be so sure? And we say, oh, it's quite simple. It's the anthropogenic emissions, and we just know this. Never, ever in the history of Earth have the anthropogenic emissions been higher. We can say that for sure. This has led to atmospheric concentrations of carbon dioxide, methane, and nitrous oxide that are unprecedented in at least the last 800,000 years. So we are living in a period of time that is different from, well, anything humanity has experienced before. And now maybe there's an interesting story. This is how we presented these four indicators of climate: observations of changing climate, indicators of changing capitalism, in one panel. That is actually how it appears in the report. It took three of us, two dear colleagues, Jan Fuglestved and Piers Forster and myself, about 15 hours in contact groups, as they're called, small breakout groups, so that we could include this fourth panel. Because some delegation were just hell-bent on not having that included with the other three. And we decided we have such an important story to tell from the story, because the cumulative CO2 emissions are the time series of CO2 emissions is so important, we were hell-bent on keeping that figure in. And we prevailed with some very strong and powerful support from Thomas and Pachi. So in the end, we managed to get this figure in and approved as we have it here. Now, of course, that was one of the arguments against this figure. Correlation does not imply causality just by itself, and I will come to the causality element of this, but you still need to show the basic observations on which later causal attribution is based. Before I go into that, I will show a time series from a period that we know much better, the last 40 years, and that is shown here. This is the greenhouse gas emissions over the last 40 years, but now not only the CO2, we have the CO2, it's largely what was gray before, which is here orange, the CO2 from fossil fuel burning, the CO2 emissions from land use in red, but we have the other two major greenhouse gases, methane in light blue and nitrous oxide in darker blue. And we have shown all of them, they have all gone up, but we see that carbon dioxide is the most important of them. Now, if you talk about importance of other greenhouse gases, you have to go through a number steps of some reasoning steps. You may see it on the left-hand side. This is called CO2 equivalent. The issue is, if you have another greenhouse gas but carbon dioxide, how do you assess its impact on capitalism in the way the heat trapping capacity of this other gas? And that is not so simple, because CO2 remains in the atmosphere for a long time, or much of it remains in the atmosphere for a long time. The others, especially methane, remains in the atmosphere for maybe 10 or 20 years. So how do you compare them? Those different lifetimes have to be brought to bear. And the way it is usually done is through something called the global warming potential. You do a conversion and ask, right, you have an emission of this greenhouse gas, and imagine that can act for 100 years, and you're asking, okay, if I emitted CO2 instead and looked at the 100-year time frame, what is the corresponding amount of CO2 I would have to have in the atmosphere for 100 years to give me the same radiative effect integrated over the 100 years? So that is how these equivalents are done. So we need a common currency, which is the CO2 equivalent. And you see, if we convert to CO2 equivalent, you can see that CO2 is about twice as important as all the others together. That's roughly the ratio, and that has been fairly robust. So what we've seen, CO2 has gone up the last 40 years. The other greenhouse gas has also gone up. CO2 equivalent has gone up, and the ratio has remained, hasn't changed too much. What have these greenhouse gases done? That is also something we can say with high confidence now. This is shown in this graph. This is the attribution. This is the attribution of causes of the observed capitalism. The way this is done in principle is that there's a combination of observations and model simulations, where in this particular case you run a series of model simulations where you include one of the drivers at a time, one of the forces at a time, just the greenhouse gases, just the other anthropogenic forcings, which are aerosols in the troposphere, for example, the change in surface reflectivity from land use is another anthropogenic forcing. You put all the forces together and run the simulations. You do simulations with just natural forcings. The natural forcings are the volcanic eruptions, which blow aerosol into the stratosphere, and the sun has variations. That's also a natural forcing. And then you may have a contribution, what we call internal variability, natural internal variability. That arises because you have variability in the climate system which occurs spontaneously. You don't need to drive, it's just there. Just the act of chance, of random events, you have that too. And then what people do is take these observations, these series of simulations, and they put it into a statistical machinery, and they can come up with attributions and say, right, a certain causal element has led to a certain amount of warming, in this case over the last 60 years, and you compare that to the observed amount of warming. The observed amount of warming is top, it's about 0.6 degrees or so over the last 60 years. Greenhouse gases do somewhat more, maybe 0.9. The other anthropogenic forcing, air pollution, aerosol, is a cooling effect, 0.25 or so. The combined anthropogenic forcings make pretty much what we see in the observed warming as the best estimate. Natural forcings have shown virtually no trend over the last 60 years. Natural forcings are wholly incapable of explaining the observed warming, and also the natural internal variability is a small amount. The whiskers tell you the uncertainty, and this is why we have to, it's a statistical, the physical uncertainty. And before any question comes up, you may be wondering, the combined anthropogenic forcing, the orange, is the sum of the green and the yellow. And you may ask, how can it be that the sum of two things, each of which has a large uncertainty, how come that the sum has a smaller uncertainty than the individual parts? It's actually quite well understood. The issue is, this whole method works with spatial patterns of warming and cooling if you drive with a certain forcing. And the spatial patterns that arise from driving a model with greenhouse gases, and if you drive it with aerosol, they are quite similar. They are not so easy to tell apart. And that means if you inferred that you had a stronger aerosol forcing, that may well be, it would imply you also had a stronger response to aerosol forcing. That would imply you also have a stronger response to greenhouse gas forcings. What one is stronger, the other is stronger too. Since they work against each other, they kind of cancel each other out to some extent. But the sum, the net effect, that can be well separated from all the other potential effects. And this is why we know the response to combined anthropogenic forcings much better than we know the response to any of the individual forcings, greenhouse gases on the one hand and other anthropogenic forcings on the other hand. The grand total of this is summarized in this sentence there, which in this case, so I'm quoting, all my quotes are verbatim from the synthesis report. There, in this case, it's a high concentration of greenhouse gases. Their effects, together with those of other anthropogenic drivers, have been detected throughout the system and are extremely likely to have been the dominant cause of the observed warming since the mid-20th century. So most of what we see in black has been caused by anthropogenic influences. And we are quite certain of it. Extremely likely, as Pachi mentioned, means that the margin of error is 5%. There's a 5% or less probability that this is not true. For most decisions to be taken in human life, 5% residual uncertainty is enough that you rely on the 95%. And these are the impacts. People have looked at what impact the observed changes had on natural systems, on human systems. Now, this is very complex. I would invite you to spend half an hour or an hour on this plot, not here, but afterwards at your leisure. So let me pull out Europe. That's where we live. And so what we have is a mixture of things. Like the snowflake you see means that change has had an impact on the cryosphere. It could be glaciers. It could be frozen ground. The tractor shows you that there has been an influence of capitalism on food production and so on. You would have to go through. And what the group coming up with this has done is to distinguish carefully about how certain are we that a certain change is really caused by climate change. There are confounding factors. There may be political changes, what have you. So if there is an open symbol, it means that the capital influence has been small. If the symbol is filled, it means the capital influence has been large. And the number of horizontal bars shows you the confidence. If it's 4 horizontal bars, it means, oh, we have very high confidence in that we can detect an influence of capitalism on this particular item. If you have a smaller number of bars, as in the bottom left with the open water droplet, we have low confidence that we can really attribute a certain impact to climate change. And so what this group has done is really gone through all the available literature and sort of try to separate capitalism from confounding factors on the impacts. And since the impacts vary strongly regionally, I hope you can appreciate that this is not something one can easily summarize. You really have to take, if you want to know, especially about a region, you have to go in and look at that region specifically. But the overall assessment is that in recent decades, changes in capital have caused impacts on natural and human systems on all continents and across the oceans. Impacts are due to observed capitalism, irrespective of its cause, indicating the sensitivity of natural and human systems to changing capitalism. A very important part of this is the irrespective of its cause. What this group has done, what is possible currently, given the current state of knowledge, is they can say we observed capitalism and we can determine whether it has had an impact. What they cannot yet say, except in rare circumstances, is whether that capitalism that has had that impact is the anthropogenic capitalism, or, if you wish, simply the capitalism that occurred. They have not tried to do that because the literature just isn't there. Ideally, of course, we want to know whether a certain impact was ultimately caused by humans, but there's very, very little research that has been done on that so far, and this is why this important disclaimer, irrespective of its cause, is important. What this group can say, there has been capitalism, that climate change has had an impact, that we know. And whether it's human-induced or not, the capital change is not clear. It's not excluded, but it's not clear either. However, why this is important is the following. If capitalism continues and becomes larger, we know that these impacts that we are seeing today will become deeper, more widespread, so it is important. These things are sensitive to capitalism, and more of it will happen in the future. So to sum up, this is our resume of the topic 1, observed changes and their causes. Human influence on the capital system is clear, and recent anthropogenic emissions of greenhouse gases are the highest in history. Recent changes have had widespread impacts on human and natural systems. And I think this sums it up. I don't have to add any more, and thank you for your attention.